Hello students, today in your geometry class you're going to be working on circles and arcs. Now at the end of this lesson you will be able to identify major and minor arcs of a circle. Now to start, let's start with the basic principles of the parts in a circle. Now at the top center we have a circle with center P. So we've labeled center at point P in the center obviously, and we have the radius, we call it CP. Then we have the diameter, which is our diameter AB. Now moving on to some new things. In the circle on the left side, we have arc TRS is a semicircle. So notice right above the TRS is that little arc, for lack of a better word. So that's pronounced arc TRS is a semicircle. Now when you have arc TRS, the angle that's formed by that forms an angle that's 180 degrees, like so. Now the center circle has three different points, R, P, and S, and T of course. Now the minor arc is the arc in red that I'm highlighting for you now as best as I can. Now this minor arc is called the minor arc, and the measure of arc RS is equal to the measure of the angle RPS. So RPS is the angle that you see created by these two radii. And notice that if we say the angle is 110, the arc length, the minor arc is 110, then the arc and the measure of those angles are going to also be 110 degrees. Now the major arc is called the major arc because it constitutes the majority of the arc in this circle, denoted by this red arc on the right hand side, or the right circle, is called arc RTS. So they give you that extra point, the T, just to let you know which direction that we're going in. Now to figure that part out, we take the minor arc and we subtract that from 360 degrees because there are 360 degrees in a circle. Moving forward, we have postulate 10.1, which is the arc addition postulate. It says that the measure of the arc formed by two adjacent arcs is the sum of the measure of the two arcs. So if we look at what they gave us below, it says measure of arc ABC. So measure of arc ABC, which is this angle in red, arc ABC. Now that arc is equal to the measure of arc AB and the measure of arc BC. So let's look at an example. In example 1, you'll notice we have a circle with center A, and they tell us that arc PAQ is C degrees, and the larger angle is 4C minus 10. Now what you'll notice is since this line down the center of our circle is the diameter, that means this has a sum of 180 degrees. So what we're going to do is we're going to find the sum of C and 4C minus 10, and we're going to set that equal to 180 degrees. So what we're going to end up with is 180 equals 5C minus 10. Then we're going to add 10 to both sides. We get 190 equals 5C. Then divide 5 to both sides, and we get C equals 38. Then we'll check our answers. And of course it matches. Now, Theorem 10.9 is the circumference of a circle, something we should all be familiar with already. It states that the circumference of a circle is pi d, where d is the diameter, or 2 pi r. So that's how we find the circumference. And if you forgot, the circumference measures the distance around the circle. It's kind of like the perimeter, but for a circle. Now Theorem 10.10 is the arc length. Now the arc length is the measure of an arc based off of its circumference. So in order for us to figure that out, the formula is the length of AB, so the portion in red, is equal to the measure of AB divided by 360 times 2 pi r. So to break this down, 2 pi r is the circumference of a circle. It gives us the measure or the distance around it. And if we wanted to find out how long a certain arc is, we multiply that by the percentage of degrees that it takes up out of 360. So notice on the equation it says divide by 360. Now again, to reiterate, we do that because we want a small portion of the circle. So basically we want, say, 30% of it, or 30 degrees out of 360 of it. So we divide by 360 because it gives us the small portion of the circumference that we want. So let's try a couple of practice problems together. In example 2, we have the given circle, and it says find the arc length for 45 degrees. So remembering the formula, we're going to use 2 pi r. So 2 pi r, and we're going to multiply that to the total amount of the angle or the circumference that we want. So we want 45 out of 360 degrees. So we want that small portion of the entire circumference. So what we're going to do is we're going to fill in the blanks and multiply. So that turns out to be 45 divided by 360 times 2 pi r, and r is 14 degrees. So when we simplify this, we're going to get this to be 7. Actually, let's break that down a little bit further. So once we do this multiplication, we find out that this turns out to be 1/8 times 2 pi r. So 2 times 1/8 is 1/4. Times 14 pi. And when you simplify that, that turns out to be 7 halves pi. Much better. So for example 3, we're going to do the same exact thing. Notice it's the same formula. It's 60 degrees out of 360 times 2 pi r, where r is 10. Then we're going to go ahead and resolve this while we're at it. This turns out to be 1/6 times 2 pi r. So 1/6 times 2 is 1/3 pi, and 1/3 pi times 10 turns out to be 10 pi divided by 3. Now it's your turn. Try solving these 3 problems. When you're done, send me a direct Edmodo post, and that's all. See you guys next time.